All right, for those of you who are watching online after the fact, we're just going through the warm-up right now. Camila shared that D doesn't stand out because it's not a rectangle. And now we're heading on to Eileen. Eileen, do you have one of these that stands out? It could be for any reason.
Number B?
All right, so you think letter B. Why B?
Because it
Could it be with how it looks, how they mark things off?
Wait, because it has squares and the rest don't?
Okay, awesome. I'm going to put has a grid.
Okay.
Okay, is that fair? Has a grid, other ones don't have a grid. All right, one more. Elizabeth, do you want to share one that stands out to you? Which one doesn't belong? Thank you, Eileen.
Never mind, it was B, the same one as Eileen.
Okay, so did you have the same reason that because it had a grid?
Yeah.
Okay. Well, very good. Yeah, there's at least one thing that stands out for each of them, and you might need to look a little bit closer to see how they stand out. But quick question before we move on. Like I said, we kind of have to move fast today. How would you find the area of each of these pictures? Any ideas? Malia?
The rows and columns?
All right, rows and columns. Tell me more.
When for the one, the C, just for the area, 4 times 6.
Okay, so you say 4 times 6. And what does that equal?
$21.
Close. You can skip count by 6s, skip count by 4.
24.
24, yeah. Good catch. So yeah, 24 for this area there. Ultimately, what Malia just did was take the columns of 4, the rows of 6, multiply them together, and got her area. All right, so good job, Malia. We can apply that to C, to B, and to A. But what about to D? How do we figure out D? We kind of talked about this yesterday. What's up with D? Malia, is your hand still raised? It is. Do you want to answer it? How do I find the area of D? You're on mute.
Do 2 times 7 and 3 times 2.
How did you know to do that?
Because there's 2 different areas. Because there's 2 different squares and rectangle.
Okay, so did you cut it like this then? So it'll show up. Why is it not showing up? There it goes. Yeah. Is that how you cut it? Yeah, so you saw kind of a weird looking shape, but you saw some rectangles inside?
Yeah.
Okay. And so you found, let's go ahead and mark this off here. So there's one guy. Come on, there we go. Here's another one. So you found the area of the blue Pop-Tart and the green Pop-Tart, and you added them together? Okay, let's find the area of the green one first.
7 times 2 equals 13.
7 times 2 equals 14.
Mm-hmm.
Okay, and what about the blue one?
2 times 3 equals 6.
2 times 3 equals 6.
Mhm.
Okay, now what do we do?
You add 14 and 6.
You add them together, and what do you get?
20.
Yep, you get 20 units. Good job, Malia. That was perfect explanation. When we have this weird looking shape, but we can see some rectangles inside of it, but we can break it up and use those side links, those rows and columns, to give us the area of each piece, and then add the pieces together to get the total area. So that's 20 square units. Katie, do you have a question?
Yes.
All right,
Are we
what's up?
supposed to write this down?
You're always supposed to write it down. Well, maybe not always, but you should have a piece of paper and a pencil ready to take notes, right? So let's maybe lean up a little bit, Katie. You seem super comfortable in that chair. I'm sorry.
Yes.
It's class time. All right, we're moving on to the next activity. All right. Now, before we get started, I want you to look at this rectangle there in gray. And can someone please describe this rectangle to me using keywords like rows, columns, and area? Camila?
There are 2 rows.
Okay.
And there is 3 columns.
All right, 2 rows, 3 columns. What's the area?
And the area is 6.
And how'd you get the area?
Because since I know 2, it's you're just gonna add 3. So you're gonna think about whenever there's a 2, you're just gonna think about addition. So 3 plus 3 equals 6.
Okay, so you can break it up like this.
Yes.
And have 2 groups of 3. You have 1 there, 1 there. So 3 plus 3 equals 6. Is that what you're thinking?
Yes.
Okay. We could also use multiplication. Can you explain how to use that?
So you're gonna put 3 times 2.
And what do you get?
6.
6. You get the same answer. All right, there are 2 ways of doing it. With something as small as a 2 by 3 rectangle, maybe you can count up those groups of units. But if you had something like 8 times 5, like a 5 by 8 rectangle, you get a bigger number, and it might be easier to just multiply, right? Now we can multiply, and if it's a big number like that we're stuck on, we can skip count from there, right? I'm not saying you can't do that. I'm just saying sometimes it depends on the rectangle that you're given to kind of move your strategy along. So nice job, Camila. Let me pull this up over here. All right, it's a little tough because we're doing this virtually, but do you see these red blocks on my screen?
Yes.
Okay. So there are 10 total blocks here. Now pretend that I gave these to you and you're able to kind of mess around with them and build and create rectangles. But as a class right now, if I gave you these 10 blocks, what rectangles could I make that use all 10 blocks, no more, no less? What's an example of one? Malia? You're on mute.
One is to put 5 for a line and the other line for a 5.
So you're saying like this maybe?
Mm-hmm.
And then one below it?
Mhm.
Okay. Can you describe that for me?
5 times 5.
What was it?
5 times 5.
5 times 5, is that how many rows and columns we have? 5 and 5?
Oh no. 2 is the rows and 5 is the columns.
Right. So does it look something? Oops, I'm over here now. I started to draw it. Something like that? Okay. So yes, we have 2 rows, 5 columns. What's our area? You can go for it,
10.
Malia, if you know what it is. You say 10? Yeah, our area is 10 square units. Oops. 10 square units, which should, I mean, in the grand scheme of things, when you look back at it, didn't we use 10 blocks to begin with? So it should be 10, right? We'd have done something wrong had we got another answer, because we only used 10 blocks. Okay, I'm going to give you a hint. There's only one more rectangle that we can make. Any ideas on what it could be?
The one that's
Malia's shaking. Malia's shaking her head. Yeah. You say one that's straight? Like straight up and down? How many units wide?
Like 5?
5 units wide? Isn't that what we're doing right now?
It's gonna be 10.
10 units wide? Like this?
Mm-hmm.
Yeah, that's a very good example. Let me draw that on my screen now. Ooh, kind of an ugly rectangle, I will admit. But something like that? Right. Area should be 10 again, because we used only 10 rectangles. Okay, how do you think we could figure out, you don't have to give me a for sure answer on this, but if I gave you 10 blocks, let's say, and I didn't say that these are the only 2 that you can make, how would you know that you've made every single one that you could make? Any ideas? What strategies could you use?
I can. I can add them together.
Add them together? Okay. Camila's hand's up. I'm going to go to Camila real fast. Thank you, Malia. Camila, go for it. What's a strategy we could use?
Multiplication.
Okay, explain a little bit more.
So you're gonna think about what makes 10. So
Okay, so what are some examples then?
5 times 2.
Okay, yeah, I was going to write it a little bit differently, but I decided not to. So 5 times 2 or 2 times 5.
And
That
1
equals
10.
And 1 times 10. Yeah, that's exactly right. Could we try others? Let's see. Could we multiply anything 3 times something to get 10? We have some that are close. Like, what's 3 times 3?
9.
Yeah, it's 9. So that's not 10. Let's try 3 times 4. What's 3 times 4? Also, I see in the chat a couple people asking about going to the page. I would encourage you to go to that page. It's page 3, I think, in your book now, in your workbook. So if you have a workbook, I would turn to that page because you'd have it in front of you. You don't have this grid here. I added the grid for me so that I could draw on the screen. Either in your packets or in your workbooks. But no, to answer this question, 3 times 4 is 12, right? 3 times 3 is 9. Both of those are not 10 and they jump over 10, in fact, as you add 3 and 4.
Yeah.
You guys follow? So 3 doesn't work. We could do the same thing for 4. But yeah, this is all we can get for 10 at the moment.
Yeah.
Interesting. Okay. So moving on to the next little thing that falls in line with the workbook and the packets. Let me scroll on over here. Okay. So I want you to build, aka draw, 5 different rectangles with a given width. Now, you don't have to do 5. We don't have enough time to get to 5. So let's maybe say 3. What you're going to do is make 3 rectangles that are 2 tiles wide. And as you do it, I want you to write the area here for each of them. And then you're going to move down to 3 tiles wide and draw 3 rectangles that are 3 wide and give their areas here. And then 4 tiles wide and do their areas here. Does that make sense? So if we were to do this 2 tiles wide one, let me come over here and start drawing. Here's one that's 2 tiles wide, right? There's a good base for us to use. And let's say I want to do 2 tiles wide, because that's where I'm going off of. And then I'll go 2 tiles tall as well. So I made a rectangle. In this case, it's actually a square. And I can do 2 times 2, and that equals 4. So my area is 4. So I'd go back over to my box next to the 2 tiles in my table there, and I'd put 4 because that's the area of the rectangle that is 2 tiles wide. Does that make sense? Okay, so come up with 2 or 3 more that are 2 tiles wide, then a couple more for 3 tiles wide, and then 4 tiles wide. So I'll give you maybe 2 minutes to do that, 2 or 3 minutes. Maybe longer if we need it. But Adelina, do you have a question?
We don't have that grid on the side of it, so how are we gonna do it?
You can draw it in the margins in the white or on a separate sheet of paper. You're not turning that piece in. Maybe draw some rectangles over here, or down below. It can be on a separate sheet of paper too, right? You're not turning this one in. Okay, so I'll give you a couple minutes to draw your rectangles. Draw them 2 wide, 3 wide, 4 wide, and I want to know the areas of those. Katie? You're on mute.
Do you need a packet? Because I don't have one.
You don't need one, but I want you to, on a separate sheet of paper, then start drawing these rectangles for me.
Okay.
Okay, so drawing them with a width of 2, or you can draw another one. Let's say we'll do one with 4. There's a width of 4, and I want to go up. Ooh, kind of squiggly. But I have 4 here and 3 there. So whatever this area is that I find, I would put right here in that area. So I'll give you maybe 1 or 2 more minutes. Okay, 30 more seconds. Try to have a couple down for each. I want to know the area of them as well. All right, let's go ahead and stop drawing rectangles. I want to hear from you guys now. So raise your hand, please, when you're ready. I want to hear 2 or 3 rectangles from each of you. Camila, you first.
So I did, the first one I'm gonna do is 3 tiles wide. So I did
Okay.
kind of like, there was 3 squares inside, and I got kind of confused, so I just put 3 times 1 equals 3.
Yeah, that's exactly right. Yeah, if you're doing only one row here, so we have 3 columns because you said it's 3 wide. Sorry, I'll scroll up just a little bit more. There we go. You said it's 3 columns wide. And if there's only one there for the row, there's only one row, our process doesn't change. In order to find the area, we still do 3 columns times 1 row, and we get 3, which makes sense because there are 3 dots or blocks inside that rectangle, right?
Mm-hmm.
So that's exactly the right thinking. So if 3 is our area and it's for a 3 tiles wide rectangle, I'm going to put right here so we can keep track of it. 3 tiles wide, area of a rectangle. One of the options is 3. All right, Camila, go for it. Let's give me a couple more.
And the next one, I did 2 tiles wide, and so I put 2.
Okay.
And then I put 1 times 1 equals 2.
So you did 1 row?
Yeah, like that.
All right, so we have 1 there, 2 there. 2 times 1 to get our area equals?
2.
2. Yep, so there are 2 there. I'll put 2 over here because there's 2 tiles wide. Go ahead and give me 1 more.
So for the 4 tiles wide, I did 2. I did 4 in each one. For the columns, I did 2, and for the rows, I did 2.
Okay. So you did a 2 by 2?
Yeah.
Okay.
And then
So this would go under the 2 tiles wide over here, right?
Mm-hmm.
Okay. So 2 by 2?
Equals 4.
Right. There are 4 spots within there. There, that's better. So over here, I'm going to do, looks like I already have one there, 4 wide, or 4 for the area I put in the first row, right over here. All right. Thank you so much, Camila. Let's hear from, I see Adelina's hands up. Adelina, go for it. Give me a couple.
Yeah. So I actually had the ones on the board. I had all of those down right here already, but
Okay.
I have one of them. On the 2 tiles wide, I did 2 columns, and I went down 8, so that would equal 16 pretty sure.
Yeah, let me get this drawn out correctly. So 2 there, 8 there, 2 times 8 equals 16. Very good. All right, you want to give us another one? Or want to come up with one together? Let's come up with one that's 4 tiles wide.
Yes. Okay.
How many rows do you want?
maybe 3.
I like maybe 3. So we have 4 there, 3 there. What's my area?
That would equal, pretty sure would equal, 4 times 3 equals 6, 12.
Yep, it equals 12. So I'll put 12 there. How about another one 4 wide? 4 wide, and let's go 2 down. That's my area.
Your area is 8.
It is 8. Let's do one 3 wide, Adelina. We're just powering these out.
3 wide?
Let's go 3 by 3.
3 by 3? Yeah. And 3 times 3 is 9.
It is 9. So I'm going to fill in the graph over here for 9. I'm going to erase all this. Let's see if I can do that. No, that didn't work. So I'll just erase it the old-fashioned way. Let's go 3 by 5.
Ooh. 15?
Very good. 3 times 5 equals 15. And let's do one more 4 just to keep it equal. Let's go 4 by 4.
4 by 4. 16?
16. Thank you so much, Adelina, for your math skills. I love it. All right. Let's erase this real fast and move on to, I know we didn't fill out all 5 of them, but it might give you enough help. Question 2, or part 2. It says discuss with a partner, but I want you to think by yourself for a second. We'll come back together. Discuss with a partner what you notice about areas in each row of the table. So what do you notice about each line? Not so much as a whole, like all of them together, but what do you notice? Is there like a pattern or something that's consistent with 2 tiles wide? Is there something that's consistent with 3 tiles wide? And something that's consistent with 4 tiles wide? Let's think about it.
Can you write it down?
You can. Yeah. All right. Sorry, we're going a little bit long today. This is how it was in block 1, too. But this is getting close to the last thing we're going to do. So thank you for your patience. So what patterns do we see? Go ahead and raise your hand. What are some things you notice about each row? Malia?
That each of them have only 3 rows that are filled.
Okay, so that's fair. Yep, there's only 3 options available. Okay, thank you. Camila?
I noticed in the 4 tiles wide that the 8, when you add up, times 8 equals 12, and 16, 8 times 2 equals 16. So it's kind of like a multiply.
It's like a what?
A multiply chart.
Oh, a multiply chart?
Yeah.
Okay, you're actually very close to what we're talking about today.
Oh.
I want to explain one thing real fast. You guys know how to skip count, right?
Yes.
Okay, so if I was to skip count by fours, I would go 4, 8, 12, 16, 20, on and on and on, right? What do you notice about the 4 tiles wide row? What do you notice about the area of these rectangles that are 4 tiles wide? Camila, go for it.
That's that kind of like skip counting.
Yeah, those numbers, these areas are on the numbers that we skip count with fours. You see that?
Mm-hmm.
12 is over there, 8 is over there, 16 is over there. All right, let's see if that pattern continues for the other ones too. Let's look at 3 tiles wide. So if we were to skip count by 3, we'd go 3, 6, 9, 12, 15, 18, on and on and on. Well, are areas over there on that list for 3 tiles wide? This middle chart there? Well, there's 3. There's 3. There's 9. There's 9. There's 15. There's 15. Do you see that? So what our main focus for today was, we haven't said the word much. In fact, I haven't said it since the daily agenda slide. But these area of rectangles here, depending on their width, the areas are what we call multiples. Okay, multiples are numbers that when we skip count by and get to, these resulting numbers are multiples of the original number. Right? If we're skip counting by 3, then 6 is a multiple of 3 because we can skip count to it when we count by 3s. 3 to 6. 9 is a multiple of 3 because we can skip count by 3 and land on it. Land on 9. Same thing goes for 15. 15 is a multiple of 3 because when we skip count by 3, we land on 15. Okay, I see a lot of people without videos. That's okay. But if you wouldn't mind coming off of, so coming on and showing your video so I can see you, that'd be great because I want to get thumbs right now. Multiple is a new word. But do you see how numbers that you skip count to and land on are multiples of the previous number, the original number? Okay, so looking real fast at part 3, predict the area of another rectangle for each width and explain your reasoning. Can someone share with me what would be an example for 2 tiles, 3 tiles, and 4 tiles wide on rectangles without having to draw it out? What number could be, or what area could there be for a rectangle that's 2 tiles wide? That's not listed here. Did I explain that okay? Do you understand the question? Like without drawing a rectangle, what's an area of a rectangle 2 tiles wide? What would be an example of one? This is the very last thing we're doing today. I know we're running a little bit long. This is the very last thing. Adelina?
Okay, so I pictured a 2 and then 2 rows and then 10 columns.
Okay. And what did you get for the area?
20.
You got 20. Let me see. Is that even? Yeah. So I decided to draw the rectangle just to have a picture. But 2 times 10 gives us an area of 20. All right. So that's an example of one that's 2 tiles wide. Adelina, could you have done that in your head? Not needing to draw a picture? How could you have done it in your head?
All right. So basically, I have a weird imagination. I can picture anything. It's weird. but I pictured it going this way instead of up and down.
Okay.
It went this
But
way.
how did you know that? Did you know before you had to draw that rectangle or think of it that 20 was going to be the area?
I was like, wait, if we're skip counting by twos, I may as well just add a 20 in there so we can keep skip counting on and on and on and on and on.
All right. Yeah, we have options when we skip count, right? We can go on for as long as we want. Very good thinking. Thank you for sharing, Adelina. Does someone want to share a 3 tiles wide? Like, what's an example of an area of a rectangle that's 3 tiles wide that we can think of right now? Now that we have kind of an idea of what multiples are, how can we, what's a multiple of 3? Malia? 6? Yeah. How did you know it was a multiple of 3?
Because 3 plus 3 is 6.
Yeah, you can skip count and land on it, right? When you're counting by 3s. All right, Malia, do you want to give us one for 4? That's not listed there.
24.
And what would you have to multiply 4 by to get to 24?
12.
Not quite 12.
Oh, 8.
4 times 3?
The baby.
Yeah.
Not quite. Let's think about it in an area model. If we were to do 4 wide, and we're trying to get to 24 squares, it would actually need to be 6 down. Because we have 4 here, we have 6 here, and 4 times 6 equals 24. Does that make sense, Malia? Okay, so ultimately, as we kind of wrap it up, I know it was a long day. We'll review on Tuesday. It's a 3-day weekend, super exciting. But we'll review on Tuesday multiples. Remember, multiples are anything that any number that we land on when we skip count. So basically, we can get a multiple if we multiply the original number by another number. All right. I'm going to come off of sharing my screen. I'll come back over here. That was a long day, really long. I'm sorry. But we had to get a pretty good start to this before the long weekend, and then we'll get some more learning on Tuesday. Are there any questions on what we did today? No? Okay, homework was posted. I'm going to move the due date to Wednesday at midnight. Usually I post it with a due date of the next day at midnight, but I want to talk more about this on Tuesday, okay? So feel free to start it. You're welcome to start the assignment. You probably have the skills that you need to do it, but we just haven't spent enough time on it, okay? So we'll go through that assignment on Tuesday together, but if you want to try starting it, go for it. I would encourage that. All right. If you don't have questions, feel free to go. It's almost lunchtime. You can look at the assignment, like I said, practice it if you'd like, but we'll have another day to do it, so we can look at it on Tuesday. All right.